2.
Yeah, hello. Yeah, hello. Welcome all for these relevant tutorials. And today we'll discuss some important topics for artificial intelligence subject, which will be having the exam for our final year students for tomorrow. So let us have the syllabus first of all. Let us have a glance at the syllabus. I guess you are able to see the syllabus on the screen now. So is the syllabus visible on the screen for you people? You can give your comments or any doubts in the live chat there. So actually the syllabus for AI contains 7 chapters, but for the examination, I guess we had only up to 70%. That is 5 chapters for the examination. So let us move into the syllabus. So there are only 5 chapters for the examination for tomorrow. So the first 5 chapters, 1, 2, 3, 4, and 5. So mainly I wish you can concentrate on the first chapter, second chapter, and the fourth chapter. Next, of course, third chapter is also important and it is simple to understand, but we assume that fourth chapter contains more important topics and you might get more marks weightage from fourth chapter. So since we are going to attempt, we are going to have 7 essay answers and we need to attempt 4 of them. So from 5 chapters, we'll be getting a question paper for 14 marks questions. So we can assume that the second chapter and the fourth chapter is important. And of course, the fifth one also. So coming to the first chapter, we generally get the introduction of the artificial intelligence. What are you going to study the concepts in this one? So basically, I'll give a quick review of what is the introduction part of AI. So basically, AI is artificial intelligence. So generally, system doesn't have any intelligence because we human has intelligence. And we use our intelligence to solve problems, and we program that and give it to system, and system uses those programs and they act like humans and they try to solve some problems, they realize things, they act according to the situations and all. But they doesn't have any intelligence. So they use the programs which we created, right, in a better way. So that's why it is called as artificial intelligence. Sometimes AI is also referred as already implemented because the topics are nothing new. But whatever we are doing, we assume that the system can do it better, right? So here in the first chapter we discuss about AI and the different tasks that AI can do. So going to the textbook index, I think I can share the textbook index now. The different tasks that AI can do. So before going to understand what is meant by intelligence, I consider that we need to know the difference between the definitions of data, information, and knowledge, and then intelligence. So simply defining a data is nothing but a collection of raw items. Right? We can call anything like a mobile, board, fan, guitar, and whatever I'm seeing in my room, I'm calling them. So they are nothing but the data there. So that is what we call as data. And information is the meaningful data. We can define information in terms of data, but most of the people will give the definition of data in terms of information, which is not so accurate because we can define information as meaningful data. There is some information like he's writing with pen, the man is walking in the rain, and so on. That's an information, right? We can get some meaning in that. And knowledge is what we get after processing the information, what we have seen in your data mining subject. There is a lot of information, you process that and you get some patterns and you get some knowledge. Now coming to intelligence, you use this knowledge in an efficient way to solve some problems or do some things or do some tasks. That is what we call as intelligence. So without knowledge, the intelligence is not useful, and without intelligence, the knowledge is not applicable. Actually. So that is what we discuss about AI in the first chapter. And the important thing is how we want to express the problem. For example, this is the problem. How we want to uh, explain the system that this is the problem, this is the input, and that is what the output that is designed. Okay, the first task is you should be able to explain what is the problem to a system. Because if you want to explain any problem to your friend, it is very easy because we know you can discuss in a common language. But for a system, the first task is it should be able to understand what the problem is. So our first main important thing is how to explain the system what the problem is. Like for example, a chess game. If a person doesn't know chess game, I can explain him the different moves, the coins and the chess board can play, and I'll ask him to use them. Okay, but how can we explain the system that the problem is this is the problem, how to solve it? So our first main task is to explain what the problem is. So for this, first one that discussed is a state space search. That is an important question we can have from this one. We represent a problem as a state space search. That is, we represent a problem as initial state and final state, and let the system understand that from the initial state it should reach the final state by applying some rules which are applicable at any stage. Okay, so the basic example given in the problem state space search is water jug problem. In the textbook it is discussed is a water jug problem, and I guess you know what is a water jug problem. Can you show it on the screen, please? What is a water jug problem? So basically, you will be given two jugs, water jugs. Okay, one is 4 gallons, the other one is 3 gallons, and there are no markings on that jug. And you are asked to uh, show just 2 gallons of jug in the 4 gallons jug, right? So that is the task given for a machine. So how will we explain that? So we explain that as a state space search. We present two jugs as two different variables, and we write the initial state as 0, 0. Right. So if at all possible, I'll give it on the board for you. I think I switched on the board. You can see that on the board. So I represent as 0, 0 as initial state. This is the state you can see on the whiteboard. Okay, so the first one represents the 4 gallons jug and the second one represents the 3 gallons jug. So this is the initial state. And our goal is to go from this state to 2, n, because we are not bothered about what is there in the second jug, but in the first jug, which is a 4 gallons capacity, we want 2 liters. That is the goal. So from here, we can define so many states, whatever the different possibilities. Like this jug contains 1 liter, 2 liters, or 2 gallons, or so on. So I can write the states as 0, 0, 1, 0, 1, 2, 1, 1, and so on. The possibilities we know. So we can expand all those states. So we represented this one as initial state and this one as the goal state. And we expect it can apply some rules. So from these set of states, we have production rules, that image on the screen there. The production rules. There are 12 rules which are defined for this problem particularly. We are only discussing one problem because there are a lot of many problems in A that are given, but the production system for this water problem is clearly given in the textbook here. So the image that contains the 12 rules of a water jet problem are given, where for the first rule will be like you can fill the first 4 liters jug, and the operation is given there. The image which has the 12 rules, the table. Right. So in each state there can be any number of rules that are applicable. We choose the best one, and if you go on passing all the states, there is a huge tree, a hierarchical tree that is obtained, and we can search in that where this 2, n state may be available. Yeah, this one. You can see there on the screen that the first rule is the x comma y when x is less than 4. That is, it doesn't contain the 4 liters in the jug. You can fill the 4 gallons. That is the operation. And so on. All the different possibilities are given in this table. That is total production rules. And in each state, not all rules will be applicable, but whatever the rules that are applicable, you can apply on them and go to the next state. So from the first case, you can apply 3 rules or else 2 rules. And the next state, you can apply 3 rules, and so on. You can apply the rules which are applicable on that state, and you can reach to the goal state. That is what we can explain that system as a this problem as a state space search. So you can define any problem as a state space search, and if you know the number of states, that is what we call as the universe of the problem, the total number of possibilities. So when you're representing this problem as a state space search, the important concept in this chapter is problem characteristics. Right, the problem characteristics. That is the most important questions, I guess, we can, in the first chapter. So the problem characteristics is given in the textbook. We have seven problem characteristics there. So first one, is it decomposable? Next one, is the solution is a straight or path, or else can you undo some steps in the solution or not, and so on. You can see all the problem characteristics are actually the steps, the questions asked before solving a problem. Once you are given a question or a problem, these are the questions which will be asked by yourself before solving that. So is it decomposable or not, and so on. Go to the textbook problem characteristics. I think it's in the slide number 32, page number 32, I guess. So there are seven problem characteristics. The first one is it decomposable or not? So whether you can break that problem into smaller instances and solve that. The next one is, can you undo some steps in the problem? Like we have discussed some problems here. We have discussed some problems here like water jug problem, chess, or something else. So chess is a game where it is recoverable, because after you placed a move, you cannot go back because the opponent will have it his turn, right? So that is recoverable. So there are seven possible questions there. Before solving any problem, you'll be going to ask by yourself, and each of these seven are explained with some example in the textbook. You can go through that. Like the first one, is it decomposable, is explained by an integration function there, right? Integration function there. And the later the remaining are explained with their own example. But sometimes the questions are asked like, explain these seven problem characteristics for a single problem. Like for a water jet problem, what are the seven problem characteristics? For that problem, you need to explain all these seven. Right, not this page. That might be another page there. Right. The next one is production system. Since we already have given the production system for this water jet problem, we can also assume that there are some characteristics for the problem production system, like monotonic, non-monotonic, commutative, non-commutative. So these are the four properties that a production system has. So from the first chapter, we go back to the syllabus copy. Best you can go back to the syllabus copy. So from the first chapter, you can have the questions like production system and the problem characteristics. Those two are important concepts. And next one, from the second chapter, is very important. Heuristic search techniques. Heuristic search. Okay, you can see the syllabus on the screen now. Heuristic search techniques will. There are actually different heuristic. What is heuristic is, there are many searching techniques, but heuristic will give you the. It's not worried about the optimal solution, whether the solution is found or not. Like for example, a traveling salesman problem. There are any combinations that you can follow, because I think everyone knows what is a traveling salesman problem. If there are n nodes, you should visit each node once and come back to the starting point. And there are two different algorithms. The first one, if you do with brute force technique, it takes n factorial ways, n factorial combinations to search. So it is very huge number, because there are 10 cities. 10 factorial is very huge number. It is almost 36 lakhs 28,400. So instead of searching all those possible combinations, what do we do is we reduce the domain. So we have a good heuristic function which is called as nearest neighbor, and the complexity is only n square there. So when it is n square, even if there are 10 cities, it takes only 100. Right. So in heuristic search techniques, the important concepts, the first one is very simple, so we're not going to that. The important concepts are hill climbing. Hill climbing. Second one is best first search. Third one is problem reduction. Fourth one is constraint satisfaction. And the last one is means and analysis. Now I'm sharing the board so that you can see that on the screen there. Right, I think you can see it on the screen. These 5 concepts. These are the important things. And each of these concepts is explained with an example here. Hill climbing is explained by a block world problem there, where we have blocks. And there they are given 2 heuristic functions. One is local and global. And when there is a local function, there are some disadvantages. So when you study each of them, you should know the advantages of that when they are applicable. Hill climbing is very simple. And then again, there are 2 types: simple hill climbing and steepest ascent hill climbing. And there are different disadvantages, or else we call them as drawbacks, uh, like a ridge plateau. Okay, so this is explained with a block solved problem in this textbook what you follow. Now, best first search is a combination of DFS and BFS. There are disadvantages and advantages for both DFS and BFS, which you come across in your data structures. DFS is depth first search, BFS is search. Now, disadvantage of BFS is it takes a lot of space because you find all the sibling nodes and the children of each node, but you never have a dead end. But in DFS, there is a chance of going to a dead end and you come back, you visit the node second time. Okay, so combining both these approaches, we have the best first search, and the algorithm discussed for in this concept is A-star algorithm, called it A-star algorithm. So you remember what is the concept and what is the algorithm that is discussed here, what is the problem that is discussed. Hill climbing, we have gone to block solved problem, the blocks problem, and in the problem reduction, you reduce the problem into AND OR graph. So here the concept is OR graphs, and here we have A-star algorithm. So this is nothing but an AND OR graph. This is nothing but an AND OR graph, right? Next one, constraint satisfaction. Now this is an important problem type that is frequent class. So we can have these 2 topics as important. One is A-star algorithm, the other one is constraint satisfaction. So mostly in these 5 concepts, we can expect an essay answer. That is a 14 marks question. In constraint satisfaction, for the problem solving, we introduce some constraints so that the problem domain is reduced. What is meant by the reduction of problem domain? Or in this case, if there are so many states in a problem space, like we discussed in the first chapter, we want to expand the entire problem space into states. But if the number of states are so high, right, it takes a lot of time to search all of them. So the constraint satisfaction will allow us to reduce the problem space and the total domain of that. And the example that is discussed in this constraint satisfaction is, so we'll write here, the example that is discussed in constraint satisfaction is cryptarithmetic problem. So here we come with cryptarithmetic problem. So the example we have seen is, we have something like 10 plus more equal to 5. This example. So even this one, the important problem in these 2 are actually A-star algorithm in this chapter. Next one is constraint satisfaction. You can explain this constraint satisfaction using the problem called cryptarithmetic, and this is the example: 10 plus more equal to 1. Here the problem, I guess everyone know the problem. We can assign each letter, each alphabet a value or a number, so that this equation is satisfied. When you add these 2, this equation should be satisfied. So initially the condition is each letter should be assigned a unique value, and no 2 letters are the same value, and it should be the same among all the equations. Like if I assign a value something like 5 to m here, in the entire equation, that contains the same equation, right? And so on. So here, what is the first thing you do is you consider that m is equal to 1, because this is the carry bit. So m is equal to 1. So after knowing this one, from this one, so on, we generate the constraints so that the number of permutations we get will be reduced. That is what the constraint satisfaction is. Because you write so many constraints, so to satisfy them, the problem space will be minimized at a very great speed, right? So the last one is means and analysis. This is also important concept, but not most frequently asked. But means and analysis is nothing but make a problem into sub problems, you solve them individually, and later you try to join them as a complete solution. And the example given in this one is robot navigation. So the example for this one is a robot navigation. How we can control a robot. So remember these topics for each. The third chapter. These are the actually techniques, and these are the problems that are discussed with this technique. And it is not that only arithmetic is nothing. Most of you what they do is if they ask what is constant satisfaction, they definitely write only this one. But actually, this is the technique name, and this is an example problem actually. There are many other problems we can do in constant satisfaction also. Like in operations research, we go with the simplex method where we have constraints. Okay, that is one more example. But actually, in this subject or else in the according to our textbook, these are the topics, these are the techniques, and these are the examples that are discussed. There might be another examples. So first thing is you need to understand what are these techniques and what are the problems that are discussed in this one, right? So this is what you come across the third chapter. According to the textbook, that is the second chapter in the syllabus copy, right? Second unit in the syllabus copy, right? Now coming to the next one, as we discussed, after 1 and 2 chapters, right? Shall we go with that syllabus copy once again? Yeah, not this one, the syllabus copy. Yeah, in this you can see that after the 1 and 2, better you go with the fourth chapter because that is a very important topic. Better you go with the fourth chapter where we come with symbolic logic. So in this topic, the important topics are resolution theorem. First of all, proposition logic, where we can find the problem like Marcus problem. We want to, when the statements are given, we write them in the proposition logic statements, and we are able to answer them, right? So the best example is the Marcus problem, what we come across in the proposition logic. Then we go to the resolution. So in the fourth chapter, according to the syllabus, the resolution theorem is very important, where resolution provides the proof by refutation. So that is, we take the negation of the statement which need to be proved, and we prove that it is false, so that the statement is true, right? So resolution does something like it will take the negation of the statement which you want to prove, and we end up proving that as false. So obviously the statement is true. That is what resolution do, right? So in that, the best example is discussed is the Marcus problem. So that is one important question in fourth chapter. And then the second part of the fourth chapter contains the representation, right? Representation of knowledge in different ways. And in that, most important thing is semantic net and conceptual dependency. Semantic net gives a clear representation of statements. You can see the examples in the textbook. So going with the semantic nets, then conceptual dependency. Conceptual dependency will explain a sequence of statements also, right? There are some examples that are given like there are several rules which are given in that for actions, each of the actions and their emotions and all. So we need to learn the 13 points which are given for conceptual dependency, and we can write any statement in that. And these are important in the second part of the fourth chapter. And possibly you can go with the script. Scripts are nothing but you explain a scene. Like the example given in the textbook is with the regarding with the view of a person who is watching a movie. So what are the properties there? What are the actions he has done? So which is entirely given as a script. Okay, and you can always go with the exercise problems which are given after this chapter. Not for all, but exclusively for the second chapter and the fourth chapter. There are some exercise problems which are repeated mostly in the previous year's exam papers, especially for semantic nets, conceptual dependency, and scripts, right? And then you can go back to the third chapter where how the representation of knowledge using the rules, where we come with the what is the forward and backward learning reasoning. So forward means you go from the goal state to the initial state to the goal state, and backward is you come back from the goal state to the initial state. And then matching. Matching, what is matching is because we have given the terms of production rules and the states. For example, assume that a problem space contains uh, some 10 rules and some 10 states. In each state, not all rules will be applicable. So initially, before solving the problem, matching here is you simply match the rules with the states which are applicable in each, so that it will be easy while solving the problem. So in the third chapter, the important concepts are forward and backward reasoning, matching, and next one is the prologue, programming, logic programming, which is a language used for putting these logics into a program. So we'll be providing the important questions also in the Jimon group at the end of the session. So after going to as far as my consideration, you can go with the first chapter, then to second chapter, then the fourth one, and next the third one, and last you can go if the time is good enough for you people to the fifth chapter. However, sixth chapter is not given for your examination. So where the fifth chapter is quite complex to understand it and takes more time, because in non-monotonic reasoning, the only thing that we have is we'll be explaining with an example of a story that which contains a truth maintenance system. There are three kinds in that: justification based, assumption based, and logic based. So it is quite complex to understand the topic. And if at all possible, from the textbook in the 8th chapter, you can go with the statistical reasoning. In case you have good enough time, go with the Bayes theorem and the rule-based systems for that. So 5th chapter understanding is very complex and is a huge chapter also. So only you can go with the non-monadic reasoning types and Bayes theorem. And one more important topic in that one is demonstration theory. So these are the important topics in the 5th chapter, right? So if there are any doubts regarding this 1, 2, and 4, you can ask now, because 3 and 5 are quite complex and it takes so much of time to understand. So basically, according to my view, you can go with the first chapter, state space search, problem characteristics, and production systems. In the second chapter, the best first search, that is A-star algorithm, constraint satisfaction, which has an example of cryptographic problem, right? And in the fourth chapter, it is very important to learn about the resolution theorem, or as resolution, where we have the Marcus problem. And in the second part of the fourth chapter, you have semantic nets, partition semantic nets, conceptual dependency, and scripts. These are the most important topics, and I guess from these three chapters, at least you get 4 essay answers and also the 2 marks questions, whatever. So you need to attempt any 4 from the 7. So it is better you go with this 1, 2, and 4 chapters first, then go with the next one. So regarding the hill climbing technique, if anyone has a doubt, you can put it in the live chat box there, and problem characteristics also. List out a topic of problem characteristics in that table. Yeah, the textbook page number 38, because you can go to that. So there you can see the 2.3 problem characteristics. There are 7. Yeah, 2.3. There are 7 subheadings in the problem characteristics. The first one is the problem decomposable? So in the next page, you can see at 2.3.1, that is explained with an integral function to solve that. So there, this problem is actually divided into 3 instances. for x square and 3x and sin square x dot cos square x differently. Okay, that is what the decomposing of a problem is. So here each characteristics which are given are explained with different examples. And in the next one, can solution steps be ignored or at least undone? There are three important points given there. If you go to the next page, which is page number 40, is it recoverable? Is it ignorable? Or is it irrecoverable? Right. So before solving a problem, we need to consider these three points, whether it is ignorable or not. Sometimes it is ignorable because when you want to prove a theorem, okay, you do some several steps, and if you feel that that is not going to yield you to the result, you can simply ignore them and you can start over again. So which gives you the concept like ignorable. Recoverable, the example is 8 puzzle problem, or else even a water jet problem is an example. Even if you the steps are not going to give you the solution, you can just recover, you can undo the steps. But irrecoverable is nothing but where, so you can see the 8 puzzle problem in the screen there. That is what 8 puzzle problem is. This is recoverable because if you do a step wrongly, you can always go back. But irrecoverable is an example like chess. When you play a chess game, when you after your move, you cannot undo that because the next chance goes to the opponent. So this is irrecoverable. And the next one is the universe predictable? In 2.3.3, the concept is the universe predictable? Right. That is, can you understand the complexity of the problem, the number of states that are available? Okay. So when there's a two-player game, it is always difficult. Right. So you can never predict the universe for some games like chess and all because it has infinite number of states. Like for example, you want to search for an element in an array of 100 items, you know it takes at most 100. But if there is an infinite array and you want to search an element, you are never sure that when you're going to get the solution. So always predicting the universe of the problem is very important. The next one is the solution absolute or relative? That is 2.3.4 at the beneath of this page. So there are some several statements given. So understanding these statements and giving this solution is very important. Right. The same problem we discussed in the resolution theorem also. Where by understanding these, you need to give the solution. And one concept is whether the solution is state or a path. That is in the next one. The solution is state or a path because sometimes in the water jet problem also, reaching the 2 comma n state is not the solution, but the path how we reach there is the solution. There, the path is the solution, but not the state. Not just reaching it to the final state, but how did we reach the state is important, right? And in slide number 45, you can see page number 45, you have the production system characteristics. So these two are the questions from the first chapter. Production system characteristics we have categorized into 4. The table you can see in the screen. So either the system is partially commutative or not partially commutative. It is monotonic or non-monotonic. So basing on these 4, you can see that whether this production system is belongs to which of the category, right? Sometimes partially commutative means you can apply the sequence of rules which will take you from some state x to y. You can use the same rules in different way and still you are able to go to the same thing. So that is what we call it as a partially commutative. So the examples are given here. So theorem proving is monotonic as well as partially commutative. Robot navigation is partially commutative but non-monotonic. Chemical synthesis is monotonic but not partially commutative. And bridge game is neither both, which is non-monotonic and also not partially commutative. So these are the 4 categories of production system, and these are the questions from the first chapter. Okay, state space search, production system characteristics, and problem characteristics. So in the second one, hill climbing technique, discusses some problems, and there are some excess problems. You can go through them because for cryptarithmetic and other, we have some excess problems there. Right, so go with this first chapter, second chapter, and the fourth chapter first. And the important questions will be provided in the link or else in the Gmail group for each chapter individually. Right, once again going with the important topics. In the first chapter, state space search, problem characteristics, and production system. In heuristic searchings, best first search, constraint satisfaction, like which are A-star algorithm and crypto arithmetic problem. And come to the next one, go to the fifth chapter, where we have reasoning, introduction to non-monotonic reasoning and logics. The fourth chapter, that is resolution. The most important is resolution, and then the semantic nets and conceptual dependency. Then go to the fifth chapter, or the third one. In the third one, you have forward and backward or matching and prologue. So these three are the important concepts. And last one, fifth one, you have truth maintenance systems. There are three. We call them as TMS, truth maintenance system. So there are three probabilities. One is justification based, other one is assumption based, and the other one is logic based. Right? And most important thing is Bayes theorem, Dambsa-Schaffer theory. So these are the important topics, and I wish you can have good enough time to cover all these topics for tomorrow. And if you have any doubts regarding this one, you can join the Telegram group and you can get the questions from there. The complete questions from the Telegram group. So thank you.
Thank you, sir, for your valuable time and also for telling all the important questions for tomorrow's exam. Hope it will be helpful to all the students. Thank you, sir, and thank you to all the juniors, and all the best for tomorrow's exam. Thank you, guys.